In this video, I take a look at the Heathkit PT-1500 Darkroom Timer. Let me give a little background to put this product in context. Photographic film developing was a popular hobby in the 1960s through 70s, and to a lesser extent still is today. With a relatively modest investment in equipment, you could develop film in a home darkroom. And like many hobbies, the amount of equipment and accessories you could buy to move beyond the basics was almost limitless, especially if you wanted to develop color film. Heathkit saw home photography as a potential market and offered several products in this area. Their product line included photo timers, darkroom computers which assisted in calculating exposure times for black and white and color film, and even a chemical processing tray. One common accessory was the photo timer. The process of making photographic prints involves exposing the image from the negative onto photographic paper for a specific length of time using an enlarger. While the time on the order of a few seconds can be estimated by hand, for accuracy and repeatability, many people use a timer specifically intended for the purpose. A typical timer has outlets for the enlarger as well as a safe light, a low wattage red light used to provide some illumination while working in the darkroom that's not sufficient to expose photographic paper. A basic photo timer will turn on the enlarger and turn off the safe light for the selected period of time. It typically also has a focus switch which turns on the enlarger continuously. More advanced photo timers may provide other features such as timers for managing the other processing steps. Typically film or prints need to be immersed in various chemicals for specific lengths of time, or for controlling other auxiliary devices. Heathkit sold a basic enlarger timer, the ET1, in the 1950s and 60s, priced around $13.95. It provided a basic 0 to 60 second timer with enlarger and safe light outlets and a focus switch. Around 1970, they introduced the PT-15, which provided more accurate timing and used more modern circuitry. I own a PT-15 and have made a separate YouTube video about it. Around 1980, Heathkit replaced it with the PT-1500, the subject of this video. As we'll see, this was a much more sophisticated timer utilizing a microprocessor. I've seen it appear in Heathkit catalogs from 1980 through 1984 at US prices of $125 to $140. Like most Heathkit products, all these timers were kits that the user had to assemble. The basic features of the PT-1500 are the following. It has a 5-digit red LED timing display with some additional LED indicators. The display brightness can be adjusted or turned off completely, and the red light was typically safe to use in the darkroom with photographic paper. And note that any flickering you may see is an artifact of the frame rate of the camera and not something you see in real life. The keyboard is liquid proof and critical keys glow in the dark. It provides switched outlets for an enlarger, 1000 watts maximum, and a safe light up to 100 watts, and optionally an auxiliary outlet for another device such as a motorized drum up to 100 watts. It supports one enlarger timer and up to 9 process timers, each up to 99 minutes and 59 seconds, or 999.9 seconds. It provides audible alarms configurable for any combination of end of interval, every second, every 30 seconds, and every 60 seconds. It also provides a 4-digit, 12-hour time of day clock. The parts for the optional auxiliary outlet were provided as a kit that sold for $15.95. Also offered as options were a single foot switch at $12.95 and dual foot switch $29.95. These duplicated some of the front panel controls, focus and start, to allow hands-free operation. I haven't been able to locate any pictures of the foot switches. The unit takes approximately 9 watts less the outlet power and can be wired for 120 or 240 volts AC, 50 or 60 hertz. While the manual says it can run on 240 volts AC, I didn't see any information in the manual or schematic about how to wire it for 240 volts. Possibly a different manual was provided for Europe and other 240 volt regions, or maybe it was never actually offered. If it was, the firmware would need to somehow be aware of the 50 Hz versus 60 Hz line frequency difference when running the timers. Looking inside, most of the circuitry is on a single printed circuit board with some additional wiring to the outlets and switches on the back of the case. Some parts of interest include the power transformer, large filter capacitor, relay, and microprocessor. The front panel keys connect via a flexible ribbon cable. Some parts, like the displays and switches, are on the underside of the PCB, which line up with the front panel. Most of the work is done by the CPU. The chip is a MOSTEC MK3870 based on the Fairchild F8 architecture. It's an 8-bit processor with 128 bytes of RAM, 2K or 4K of mass programmable ROM, I/O ports, and a programmable timer. The clock is run at 3.5795 MHz, which is a common crystal used in color TVs. As the CPU uses a factory-masked ROM with the Heathkit firmware, it was not available from any source other than Heathkit. Some transistors are used to drive the LED display. A 555 timer IC and transistor make the tick and alarm sounds under control of the CPU. An internal trim pot adjusts the sound volume, which comes from a speaker on the underside of the case. Some transistors drive the relay, which switches the enlarger and safe light outlets. A test mode, set by a jumper, runs the unit in a mode where it cycles all display segments and tests keyboard keys. This made it easier for a kit builder to verify assembly. The power supply generates 7.5 volts DC unregulated to drive the relay and displays, and regulated 5 volts DC for the ICs, including the microprocessor. It uses the 60 Hz AC line to drive the time of day clock. Some parts on the PCB are omitted as they're part of the optional auxiliary outlet kit, which used a triac to switch the aux outlet on and off. It's housed in a metal case with rubber feet. The rear panel has the line cord and outlets for enlarger and safe light. The third outlet's covered and is for the optional auxiliary outlet. 2 grommets cover the holes for the optional foot switches, which would have connectors mounted here if they had been installed. A switch turns the display on and off, and a control adjusts the brightness of the front panel LED displays. The unit can be operated with the display off with no visual feedback if desired. Let me run through the basic features controlled by the front panel. On initial power up, you might want to first set the clock. There's no battery backup, so all the timer settings in the clock need to be set on each power on. Pressing the clock button puts the unit in clock mode, as indicated by the letter C on the display. We can initially set the clock by pressing the hour set, 10-minute, and minute set switches to set the hours and minutes of the current time of day. The current time is now 8:46. As long as the unit is powered up, the clock now keeps time using the AC line frequency, making it typically very accurate over the long term. Hitting clock at any time will toggle between the time of day's display and timer mode. Hitting the seconds key will show the minutes and seconds. And pressing the clock hold key will stop the clock. The most basic timing function is controlling an enlarger. I've plugged an outlet tester into the enlarger socket so you can see when it's active. The other safe light outlet is turned off when the enlarger is on and on when the enlarger is off. In timer mode, pressing the enlarger key selects enlarger timer mode, as indicated by the letter E on the display. If we want to manually turn on the enlarger for focusing, for example, we can press the focus key to toggle it on and off. An LED next to the button indicates the state. To turn the enlarger on for a specific period of time, we can enter the time using the keypad in minutes and seconds. For example, 1, 2, 3 for 1 minute and 23 seconds. Pressing clear will clear any entry. Let's enter 5 seconds. If we now press start, it will start the timer, turning the enlarger on for 5 seconds and then turning it off. Note that the start button as well as the step button have bumps on them that you can feel, as well as glowing in the dark. Often you'll use the same enlarger time several times. If we enter a time, say 5 seconds again, and press L, it will load the time into memory and save it. Now, at the end of a timer run, it will reset back to the 5-second timer time. The hold key will suspend an active timer. Pressing start will continue the countdown. The alarm settings keys allow setting audible alarms on various conditions. At the end of a timer, every second, every 30 seconds, and every 60 seconds. You can individually select any of these alarms or clear them all with the off button. As an example, we can set the enlarger timer to 10 seconds and select an alarm every second and at the end. When we start the timer, we hear a beep every second and a longer alarm at the end of the timer run. As well as the enlarger timer, there can be up to 9 process timers. These are typically used to time how long film or prints are in different chemical processing stages. For example, if you're familiar with the developing process, process 1 might be the developer, process 2 stop bath, process 3 fixer, and process 4 hypo or water wash. Pressing proc goes into process timer mode as indicated by the letter P on the display. You can then enter a process number, 1 to 9. Then enter the timer value in minutes and seconds. Pressing L will save the value in memory. You can program up to 9 different process timers. For example, let's set process timer 1 to 1 second, 2 to 2 seconds, and 3 to 3 seconds, and save them all. Now if I select process 2, I can click on start and initiate the 2-second timer. If I select process 3, it will run that timer, 3 seconds. The process timers don't affect the enlarger or safe light outlets. However, if the optional auxiliary outlet is installed, the unit will turn the aux outlet on when a process timer is running. The alarms I demonstrated for enlarger mode also work in process mode. I imagine the most useful would be the end alarm to notify you that a process is complete. This could be to remind you when you need to change chemicals in a developing tank or move prints to the next chemical tray. Finally, there's an auto step mode that can be toggled on and off with the step key. When the auto step mode is enabled using the step button, when an enlarger or process timer completes, it automatically advances to the next programmed timer. For example, here we can run the enlarger timer followed by the process timers 1, 2, and 3 in sequence, each time pressing start to start the next timer. So first enlarger, and when that completes, process 1, process 2, process 3, and now back to enlarger. Pressing a key that's not valid at any time will produce a beep. For example, in clock mode, hitting a number key. The manual includes instructions as well as flowcharts explaining all of the modes and keys in detail. I bought this unit in an online auction in November of 2023 in Ottawa, Canada. It came with an original manual with all of the fold-out and schematic pages. It was in good condition with some minor scratches and seemed to be working when received. The unit doesn't have the optional auxiliary outlet or foot switches, but it did have 2 external wires coming out, so the previous owner must have set up their own external switch of some kind. The light scratches and external wires would indicate that the unit was used for developing for some period of time. I did a visual inspection and some basic cleaning of the unit. I removed the external switch wires and added a rubber grommet to cover the hole where they came out. The only component checks I did were to check the value and ESR of the large 6800 microfarad filter capacitor, and it was good. I also tested the 5-volt power supply voltage to make sure it was within spec. I ran through the test mode, which is activated by a jumper. It checks the display and keyboard keys, and all was working correctly. All timer functions worked properly. I set the time of day clock and let it run, and it was still correct after 24 hours. The date codes on some of the ICs are from 1980, which would be consistent with the period that the unit was offered. My father did film developing when I was a kid in the 1970s, and I often helped him in the darkroom. We owned a Heathkit PT-1500 Darkroom Timer and used it to control the enlarger. I can see how the PT-1500 would be even more useful, particularly the process timers, which would reduce much of the tedium of manually timing the different process steps. I don't know how popular a product this was. They show up for sale on sites like eBay, but not in large numbers. That could mean that not many were sold, or it could be that most were discarded as film developing became less common. The manuals seem to be rare. I didn't find any copies on the internet. I've scanned my copy and plan to upload it to some of the manual sites. From a cursory search, I've not seen any other darkroom timers with this level of functionality. It seems to be more advanced than most other competing products. Using a microprocessor meant that they could implement many features in software, like the time of day clock and support for 9 process timers. Taking inflation into account, $140 in 1980 is equivalent to over $550 today, a significant cost and more expensive than a basic darkroom timer. There would have been a significant investment for Heathkit to write the microprocessor firmware and have MOSTEC make the masked ROM CPU chips. I've only seen it in Heathkit catalogs from 1980 to 1984. If it was only sold for a few years, it's possible that Heathkit never made back their research and development costs on the product. Since it's been over 30 years since Heathkit left the kit business, we may never know.